why do developers spend way more time configuring infrastructure than actually writing code? I mean, what if just one platform could automate all of that? Welcome to this explainer. Today, we're diving into a massive shift in how software gets built. We're moving away from those fragmented manual processes and stepping into the world of highly streamlined automated environments. We're fundamentally rethinking the developer experience, stripping out all that friction and demystifying exactly what an internal developer platform looks like in 2026 and beyond.
So to really grasp the solution here, we first got to unpack this infrastructure bottleneck. Picture this. You're a highly skilled software engineer, right? You were hired to build amazing, innovative products. But instead of writing code for that groundbreaking new feature, you spend your entire week stuck waiting on IT tickets just to get a simple database provisioned. You're constantly fighting with cloud configurations, wrestling with IAM roles, trying to untangle deployment pipelines. It's exhausting. As cloud-native environments get more and more complex, organizations are hitting a serious wall that is absolutely crushing developer productivity. It's a universal pain point. It leaves engineering teams totally frustrated, and it slows business momentum to a crawl.
And the cognitive overload crisis right now? It's honestly staggering. Research shows that developers are spending roughly 42% of their time on maintenance, configuration, and technical debt. 42%. That is time not spent on new value creation. Think about the opportunity cost there. To put that into perspective, if you scale that up to a 500-engineer company, that lost focus can cost up to $37.8 million every single year. But hey, the financial cost is really just one piece of the puzzle. The ground reality is that developers are literally drowning in infrastructure complexity. They're overwhelmed by the sheer number of tools they have to master just to get their code running, which means they aren't creating the features that actually drive the business forward.
Let's look at the traditional setup for a second. It's a world filled with frustrating, ticket-based operational bottlenecks. Developers need something, they submit a ticket, and they wait and wait. This delay inevitably leads to shadow IT, where teams just start spinning up untracked, insecure resources out of sheer desperation to bypass all that red tape. You end up with a totally fragmented toolchain where every single team is basically reinventing the wheel. Now contrast that with a streamlined, self-service developer experience. We're talking about moving to a world of standardized, golden paths. This means developers are given pre-approved, highly optimized routes to get their applications deployed safely. Provisioning the exact infrastructure you need takes minutes. It completely eliminates weeks of waiting and, frankly, the temptation to go rogue.
Okay, so in really simple terms, what is an internal developer platform, or IDP? It's a curated setup of tools, services, and automated workflows that help developers build and deploy software entirely via self-service. Think of a high-end restaurant kitchen. A master chef should focus completely on designing the menu and cooking incredible food, right? You'd never expect the chef to build the stove, install the exhaust fans, or plumb the gas lines before the dinner rush. Well, an IDP does exactly that for engineers. It handles all the underlying plumbing and complex infrastructure, giving them those paved roads so they can just focus on what they do best, writing code and delivering phenomenal software.
Now, it's super important we distinguish the engine room from the front door, because these terms get mixed up all the time. The platform itself is the back-end automation engine. It's doing the heavy lifting, connecting your CI/CD pipelines, your infrastructure as code, and your Kubernetes clusters. The portal, on the other hand, is the user-friendly interface that sits right on top. It's the front door that developers actually walk through, complete with service catalogs, project scaffolding, and scorecards. Developers log into the portal to request their resources, completely shielded from that immense complexity grinding away in the engine room down below.
In a real-world enterprise environment, these layers stack together beautifully to create a cohesive ecosystem. At the very top, you've got that user interface, the front door we just talked about, which is often powered by something like Spotify's Backstage. Beneath that interface, the architecture integrates a robust security layer, continuous integration tools, and comprehensive observability metrics. And all of these operational capabilities rest firmly on a highly resilient, shared cloud foundation, typically using container orchestration like Amazon ECS or EKS. When it's architected correctly, a developer never has to interact directly with that bottom foundation layer. The platform just seamlessly brokers that entire relationship for them.
Let's walk through an example. Imagine a developer needs a brand new staging environment to test a feature. Under the old system, you're looking at a multi-day email chain. But with an IDP, the process flows flawlessly through a few automated steps. First, the developer simply clicks a button in the portal or uses a CLI command to submit their request. Instantly, the platform validates that request against strict organizational policies and security checks.
Once it's approved, automated provisioning takes over, seamlessly spinning up the necessary resources using infrastructure as code. Finally, the application is deployed and monitored. What used to take 3 weeks of painful back-and-forth communication now happens automatically while the developer goes to grab a quick cup of coffee.
To make this magic happen, platform teams assemble a really powerful toolchain, carefully selecting technologies that bring specific value to the whole lifecycle. By 2026, a standard stack revolves around some seriously best-in-class components. You've got Backstage providing a unified, friendly face for the UI. You rely on Kubernetes as the unbreakable shared infrastructure baseline. Tools like Argo CD provide incredible value by enabling self-healing GitOps delivery. That means if an environment ever drifts from its desired state, Argo CD automatically pulls it back to safety. You utilize OpenTofu or Terraform for predictable, repeatable infrastructure. And crucially, platforms embed tools like InPhysical directly into the workflow to lock down secrets and identity security. That ensures nobody ever accidentally commits live AWS keys to a GitHub repository, which is an absolute lifesaver.
Now, I know exactly what you're thinking. What about security? Security often gets a bad rap as a hurdle that just slows deployments down. But in a mature IDP, security acts as a powerful enabler. Governance and guardrails are literally built directly into the platform fabric. Because tools like strict role-based access control and policy as code engines, things like Open Gatekeeper and Kyverno, are constantly checking configurations in the background, developers don't have to wait 2 weeks for a manual security audit. Add in automated vulnerability scanning and hard limits on resource quotas to prevent massive, unexpected cloud bills, and you have a system that is secure by default. Every single self-service deployment automatically meets the organization's strict compliance standards without a single meeting required.
And this brings us to a highly debated topic in the industry right now. Is platform engineering replacing DevOps? Absolutely not. DevOps is an operating philosophy. It's that vital culture of collaboration, communication, and shared ownership between development and operations. However, asking every single developer to be an expert in the entire operational stack, that leads directly to burnout. Platform engineering is the evolution that makes DevOps actually scalable. It's the practice of building those reusable internal platforms that allow teams to embrace a DevOps culture without having to reinvent the infrastructure wheel every single time they start a new project.
Let's talk about the human impact of this shift for a minute, because it is incredibly profound. Anyone who writes code knows the absolute pain of being pulled out of a deep flow state to go fix a broken environment pipeline or debug some random server configuration. Researchers actually call this infrastructure anxiety. In a recent study evaluating organizations post-adoption, context switches related to infrastructure dropped dramatically, going from 6.2 interruptions per hour down to just 2.1. That represents a massive reclaiming of deep focus work. It protects a developer's absolute most valuable and finite asset, their uninterrupted attention.
And when we look at the hard business payoff, the return on investment is just undeniable. This is the ultimate proof for engineering leaders. 6 months post-adoption, organizations are seeing truly staggering jumps in deployment frequency. One organization analyzed saw a massive 340% increase. Others jumped 180% and 95%. You are radically speeding up your time to market, delivering value to your customers faster than ever before. And because you're using those standardized golden paths, this immense speed actually comes with higher system stability, fewer outages, and significantly less late-night firefighting.
Ultimately, the absolute biggest takeaway you should remember from this explainer is that IDPs completely abstract away operational friction. They provide the intuitive self-service tools, the underlying automation, and the built-in guardrails so your engineers can transition away from managing all that plumbing. Instead, they get to do exactly what you hire them to do, deeply focus on building innovative features and driving your product forward. If you found this explainer helpful, please like, share, and subscribe for more AI, DevOps, cloud, Kubernetes, and platform engineering tutorials. Let us know in the comments which DevOps topic you'd like us to cover next. I'll leave you with this. As infrastructure becomes increasingly complex, will your team adopt a platform to pave the way forward? Or will you be left managing the bottlenecks of the past?